Hi, everyone. You're listening to the podcast by and for Angelneers, a Silicon Valley community of startup builders where experienced operators share their firsthand knowledge on how to build and scale startups. I'm your host, Oleg Kujakov, and our guest today is Cameron Turner, CEO of Datorium, a company that creates AI solutions for Fortune 500 companies and major organizations. Cameron has led a number of startups, he's an angel investor, and has authored several patents and publications. Today, we're going to discuss the ethics of AI, but before we get into that, Cameron, welcome to the show.
Thanks for having me, Oleg. Excited to be here.
We're excited to have you. You were with a number of exciting technology companies throughout your career. Can you tell me a little bit about where you've worked in the past to get us started?
Yeah, you bet. So I had the sort of pleasure and punishment of growing up in Silicon Valley in the 90s professionally. Started out working at Microsoft on the PowerPoint team, which is a tight knit group. It was an acquisition that Microsoft had had and was sort of responsible for being the voice of the customer. And that got me on the path of data from a very early start career wise. Since then, I've been working in data one way or the other. In 2005, started a company called Clickstream Technologies, which I grew in Berkeley for about 6 years. And then we exited that to Microsoft in 2009. And I went and ran the telemetry team at Microsoft that's responsible for doing all of the Windows error reporting and usage reporting and that sort of thing for all of the internal product teams as well as the 1,300 partners around Microsoft. So a lot of different scenarios for applying data to some pretty big business problems in those days.
Before we do the show, I like to sort of peruse LinkedIn and just check out what the guest is all about. And looking at your LinkedIn, there was just so much there to pick from. So yeah, doing a lot is kind of a understated. When did you go from data to artificial intelligence? How did you get started in AI?
Yeah, that's a good question generally. And if you think about what the differentiation is between what people call big data, business intelligence, analytics, machine learning, AI, these are all terms that get batted around on the front page of newspapers now. It used to be kind of an
Mhm.
esoteric area that people studied. But fundamentally, if you think about all of those things, there's a split that occurs when you go from reporting on history and looking at data and talking about what has happened. And you can do that in a number of interesting ways. But when you go from that context into talking about the future, and that comes in the form of prediction, probability, recommendation, these are all things that are looking from the point forward. And underneath the hood, when you think about those kinds of systems, the mathematics really changes around a lot. You go from what you could think of as Excel math, which does a great job for so many scenarios, into a space that requires more tooling and skills. And so for me, having grown up around large data sets and doing lots of the former type of research, including what we did at Clickstream, which was, our tagline was, we can tell the world what people did on their computers and devices yesterday. And we were the only ones who could do that, but it was still yesterday. So there was a challenge there for us in terms of moving from that model into being able to say meaningful things about where the business should go and where we think it will go with and without the influence of interventions in the forms of programs or consuming recommendations. So for me personally, I saw an opportunity to sort of learn that space, and that took me back to Stanford to do a stats degree focused on AI. But I think since then the world has really shifted to this approach where now it's built into really everything we do, from driving to refrigerating. Predictive AI is baked in, and so I think for a lot of scenarios, especially crucial scenarios around global problems that we're facing right now, we're remiss to not take advantage of what we do know about the history and apply some sophistication in terms of how we process that data and convert it into meaningful recommendation that can actually improve things in a state that in a way that we like.
That was an awesome job of sort of taking those big buzzwords and breaking them down, explaining them. I thought that was so interesting. You mentioned, you studied statistics and AI, and like you're saying, sort of the data driven data analysis is a it's work around capturing data and analysis, if I'm correct, and then AI is like the logical next step. And it sounds like with what you studied, statistics and AI, you're sort of doing both of those. So can you tell me a little bit more about maybe what you studied at Stanford and what that program was like?
Yeah, well, before the show, also, we were talking about architecture. And I think one of the things that's lost in a lot of the literature on AI, and especially in the research, is how much AI intersects with human experience. And what I mean by that is that at the end of the day, even systems that are designed to be entirely mechanical. So, take, for example, HVAC automation on a large scale, how you heat and cool a building. You think about that as industrial scenario where there's an optimization to do and it's mostly machines that you're controlling and the outputs are something that you think a comfortable room temperature. Well, it turns out even in
Mhm.
something as structured as that space, the human factor is paramount. You have people with anyone who with a thermostat in a building will be modifying that thermostat. Anyone who has control of the building automation system will also be turning the dial. So you have all these humans with different motivations and psychology and influences, not to mention literal comfort levels for what they want the temperature to be, that are going to be messing around with the dials. And I think if you think about that analogy and then expand it out into all the places where AI is applied today, autonomous vehicles, recommendations for loan systems, hiring and firing, performance reviews, sales automation. I mean, these are all extremely human based systems. So, going back to your question in terms of like how it applies, I think at the end of the day, we can sometimes forget that all of these systems have to be deployed into essentially some form of a human environment. And I guess that's where I sort of fall back to architecture training, because that's kind of how you think about building a building. It's a system that you're building for humans to work inside of. And most of the computing systems that we have today consume more of our mind share even than the physical surroundings that we sit in.
That's so interesting. So AI is built up of data models and predictions. So let's talk about some of the ethical issues that come from those places. And I guess the logical place to start is with the data. So how can data be biased?
Well, I think a place to start with this is that all data is biased.
What do you mean by that? Yeah.
Yeah, well, I'll give you the geek answer and then I'll give you the real answer. The geek answer is that if you're performing a sample of a population, then to presume that you have a true representation of the population based on your sample is irresponsible. And there's almost no case where you can have a true sample or even consume the entire population. And a lot of the systems and marketing material, I'll say, out of big data was more about that. If you can know everything about everyone, then there is no bias because you have all the data. The challenge with that, of course, is that you're going to overpay for a system that you could probably build for 1/10 the cost and 10 times the performance with a good sampling methodology. So that's the sort of the technical answer to your question. I think the general answer is that history itself is biased towards history. And when we think about AI and specifically prediction and machine learning, we're wanting to do something with that to affect the future. And so you make an assumption right out of the gate that history will tend to predict, or what's happened historically will tend to hold going forward. Well, there's two problems with that. One is obviously that the world changes, and so your data doesn't yet represent, even in time series data, your data doesn't represent what's happened in the current moment. And the second and more critical one is that your intervention by introducing something that will change what's happening presently will itself change the nature of reality. And if you don't account for those dynamics in your model building, then you're going to skew off in a direction that you probably don't want to go. And that's where bias really gets you into trouble. And it really takes us into challenges and polarity and a lot of what we see in the United States and in the current political climate, is directly related. We know it's directly related to these algorithms that have done that intentionally.
Mhm. Okay, so I guess if data is biased regardless, what are some best practices around capturing data?
Yeah, it's a great question. I have a very pragmatic answer, given that we spend a lot of time building and deploying and then watching these things succeed or fail in the wild and hoping to iterate and improve them. I think one comes down to a very simple idea, which is that generally when you're building a model, in a lot of contexts in AI, you have an outcome and you're training against that outcome. So you have a whole bunch of data on one side of the equation. And on the other side, you have
Mhm.
something that will or won't happen. A patient lives, a patient dies. Someone commits fraud,
Mhm.
someone does not commit fraud. Someone clicks on an ad, they don't click on the ad. There's most AI sort of can be boiled down to some form of that. The vehicle crashes, the vehicle does not crash. The challenge with that is AI is very aggressive about solving for that. It's an optimization. So it's going to do everything it can to optimize the response variable, or the Y, call it, based on all of the input data that you've given it. Now, unless in your response you have some capture of the ethical things you care about, gender equality, racial equality, any form of selection that you want to do naturally. And that all has to be accounted for in your approach. Because if it's not, the AI has no conscience. It will do everything it can to improve that outcome. And this is where we get into trouble ethically, because ethics in my mind is really something that we just haven't accounted for in the modeling process. And that makes it sound simple. It's not, because at the end of the day, we don't actually know what does and doesn't matter or in the future, or what does and doesn't matter in other geographies, for example, in order to be compliant with local law. And these are challenges that large companies have when you build something that works one place and you're hoping to expand that into other places. But if you haven't accounted for that, or worse, you don't have any data to train on in that new context, and you substitute or surrogate data from elsewhere in order to solve for that, you get yourself into some really hot water.
Going back to that, like the best practices portion is a best practice just to use all sorts of different data sets when you're training these models. Like, what can you really do to avoid? I guess you can't avoid a biased outcome, but like, what can you do so that these technologies are, scalable and reusable in an ethical way?
Yeah, we've sort of blended two topics here, I think, which is data bias and algorithmic bias, and they're different in a way,
Mhm.
but the solution is a continuous problem, and I'll say that because just the context is going to change continuously, the approach would also need to change continuously. I mean, there are some standard things that we will do, things like U.S. for consumer type problems, we can look to third party data sets like US Census and Household Survey in order to do correct model weighting. We can build quotas based on what we believe to be sort of the ground truth of the thing that we're trying to not bias away from. So it comes to sort of zooming out from ground level and the data set that you have into any higher form of truth that you might have about that same context. And we look for that a lot. And there's actually quite a lot of information available out there. The government is becoming, in the U.S., is becoming more progressive, and in other governments as well. But there is no golden solution. There's no golden certification to say that you've achieved some state of non-bias in AI. One
Mhm.
thing I've heard, this morning I was listening in on VentureBeat's conference, and Barak Turovsky, who runs the Google AI team, was talking about their crowdsourced platform. And this is kind of an interesting approach where you say, well, you know what? We can never actually become the authority on what is good and what is bad, but we can actually know with some level of statistical certainty what the world thinks. And so turning the question back to the audience to help answer is one approach. Now, today that's done sort of systematically and through a separate channel, but already building feedback loops into AI such that you can retrain it based on corrections and nudges given not only by the operators, but by those impacted by the outcome, certainly has to be part of
Mhm.
the solution. And I think it's a natural thing. We have customer service centers for every major brand, And that's an opportunity for people to provide feedback and achieve a correction in some matter that they're experiencing relative to that company. And I think AI is no different. We have to build those systems back in and use them as signal to retrain those systems and do that very quickly in order to keep pace, not only with corrections that need to happen, but also changes that are happening in policy as well as public opinion.
One interesting thing you said of many is there is no gold star or cookies handed out for you've reached this level of ethics in your AI. How do you build in those systems? Like, is it a reward system? You mentioned feedback loops. How do you design systems that will get iterated on and improved? Because, like you said earlier, like these AI algorithms are sort of ruthless in how they optimize. So, yeah, how do we build these things so that they, at the end of the day, operate in an ethical way?
Yeah, it's a great question. I think the answer is just slowly and carefully, which isn't a capitalist virtue, but that's the reality. I mean, if you can't go fast and break things in a specific context, say healthcare recommendation for patient treatment, medication, then the only way to move forward is through slow measures that are where the response is carefully evaluated, and then make adjustments, as you continue to move forward, which is sometimes difficult. It's especially this podcast series about being a startup founder, which I am, and I definitely feel the two sides of my brain in conflict, where the one side sees a signal and wants to run with it and make a Boolean claim about what's going on in the world, which is the entrepreneur in me. The other side wants to draw a distribution of the outcome, which is a completely different way of thinking about the problem. And I think that's still being resolved in Silicon Valley today in terms of how to think about the complexity and gray area of AI relative to the need that the world has to have clear signals that they can move forward with.
A lot of key things there. Like, I'll start with gray area. These technologies are so impressive. They can do so much, but there is so much gray area, ironically, with these machine systems that operate on a digital level in an analog world. But the result of that is that there is a lot of gray area and a lot of important questions to ask. And the move fast and break things approach, it's one thing when you're designing a social media platform, but it's another thing when it's in an industry where people's lives are involved. Do you think there might be a second coming in the Bay Area here where our approach to designing technology it will shift? What do you sort of see in the next 10 years when it comes to these kind of challenges?
Yeah, it's a great question. I like to say that gray area requires gray matter. So you're bringing up an issue of human in the loop systems. So if you take an example of a scoring system, say we're scoring fraud, and the value that comes out of the AI is a 0 to 1 number, and it ranks everybody. We've built these systems before. When you look at the 95.95 and above, it's pretty much always right. When you look at the zero point 0.5 and below, it's also typically right. Everything in the middle is a bit of a question mark. And what you need at that point are people to look critically at what's coming in and what's going out and sort of think about what might be missing. And if there's exceptions and broad exceptions, and there usually are, that you catch it on the next go around and try to grab it. In terms of trends and where I think things are going, right now, data and data engineering, computer science, data scientists, data departments are often siloed a bit from customer experience, siloed from marketing, sometimes siloed from product design, unless the product itself is a data product. And I think one of the things that we're realizing is that the capabilities of integration of a lot of different disciplines really wins the day. So what I mean by that is that things like web design, straight design, so artists working on improving the website, for example, the customer experience, the click-through friction that occurs from first brand impression through to purchase. Those are things that can sometimes in firms be fed by data or be data driven, but they're not necessarily integrated. So when you think about now the context of human in the loop systems, you've intentionally put people, not just data scientists, but really domain experts and especially experts about the outcome that you want right in the middle of the process. And we're already seeing some great examples of this if you look at radiology and in healthcare, where you obviously have an MD consumer recommendation prior to implementing it with a patient. But that human in the loop, the physician who may have had a couple of epidemiology classes in their first year of med school, and that's kind of their data training, they become the primary user of an AI system. And because of their feedback, the primary designer of it as well. And I think those are great wins, because when you do have a human in the loop, you get not only the benefit at the, let's take healthcare at the point of care and the time of the interaction, but you're also consistently retraining a model based on what's being fed back in. So in terms of one trend, I would say that's something that we'll see is non AI specialists being directly integrated into AI systems and training.
It's really exciting to see how these AI systems can, I guess, augment, what we can do as humans. One example for me is like I play chess on chess.com, and after my games, I like to analyze them. And so then I'm almost handing my game over to the machine, and it takes it in and looks at it and spits out some data and tells me, oh, you could have done better here, here, and here. And then I'm constantly improving by doing that. So I do think that's another example of sort of integrating AI with what humans do. And I do think that is the future. I think you're totally right. One thing about how these things work is that they're hard to understand, almost impossible, because a lot of these AI technologies are black boxes. Given that there's ethical concerns around AI, and you have to sort of understand how a particular decision was made at times, how do you open that black box and sort of take a look inside?
That's a great question. And the tagline for that is AI explainability. And it's something that we focused a lot on at Datorium over the last couple of years. And there's a few different ways to approach this. I think fundamentally the answer is that you can only go so far with opaque algorithmic solutions as the situation will allow. And so, as you pointed out, model explainability and in compliance scenarios, auditability are their table stakes for the solution. So without that, you can't really deploy. And that's sort of the extreme case. But I will say that even in integration, for the kind of human computer interaction that I was describing before to occur, you have to have model explainability in order to generate a trust in the technology. And people have to see that the dynamics occur in a way that actually improves the outcome, not only based on whatever the business case is, but in a way that hasn't done some violation of ethics or practices and standards that weren't built into the training to begin with. So we've started to look at this is taking the best outcome that we can get in terms of accuracy, and then comparing that to explainable models that might serve as surrogates to the production model, but give people insights into exactly what the mechanics are that derive the outcome. And this is, I think, crucial, because if you can't explain why someone is a 0.95 or why someone is a 0.05 on some scale, then you haven't really given anyone any levers to continue a conversation or to improve that. So there's a straight line relationship between model explainability and AI explainability and meaningful recommendation, because generally your recommendations will come out of what you've trained against. And if you can't understand the effects of that training data, then you've sort of not satisfied or given the operator any way to change what they're seeing in terms of the prediction.
Can you explain just a little bit more about model explainability? Is that like an interface between the model and the user, or what exactly do you mean by that?
Yeah, it's a hard question without an easy answer. I mean, there are ways you can summarize and roll up and show, for example, the relative importance of different things that you feed into, say, a machine learning system. But one thing that that does is masks the complexity that might occur based on interactions. So, for example, something that's true in one zip code could be radically different in another zip code. And if you haven't accounted for both of those variables in the outcome, then you can't make a rule of thumb about any one variable as something that's independent. I'm not sure if that's a great answer.
These are all kind of hard topics.
Yeah, let me take one more run at that. I think there's a relationship here between explainability and recommendation. I think there's also relationship here between explainability and data visualization. Fundamentally, people are driven based on what they see and they're impacted by stories. So if you can take a model that's doing pretty well on accuracy and then make it make sense to people in a way that sort of satisfies intuition and satisfies the way that they do their work and the outcomes that they're going for, then you can succeed. If you introduce a lot of mathematical complexity and a lot of quantitative reasoning into that process, you're making it difficult for the audience to do anything with what you've built. And so that's something that we spend a lot of time thinking about is how can we take something that is derived completely computationally and convert it into something that is qualitative and can be consumed at a human level.
It's kind of about packaging that mathematical model, and I like how you said data visualization, because that's one of the best ways to take numbers and numerology and sort of explain it. So designing these things in a way that these models are powerful and they're doing what they got to do, but they can also interface with people is important. And it seems like, I mean, that sounds like almost the biggest challenge, but super important for those feedback loops that we were talking about.
Yeah, I'll give you one example. We can collect information about what people are doing throughout the day on a website. If it's a web blog, we can look at computer interactions, we can build time series, we can look at markets and trades. And then based on that, we can build models that will sort of show you what the most common paths are through a certain system. Think of it as a tree with different thickness of branches in certain areas and different thickness of trunk in another area. And so giving people that overview that gives you sort of an overall view of the landscape, but then drilling down to one particular scenario and being able to say, this is one customer's experience who failed using our technology in the example where you're looking at a weblog, for example. And if you can take that and walk people through that story, they'll feel like they know that person, and that really caters to the way humans are wired to hold on to stories in a way that can be repeated and told and used to build a business case in a business context. But when you combine those two, qualitative and quantitative, and basically are able to tell quantitative stories using quantitative underpinnings, now you know that that one story, for example, might represent 30% of a population that you care about. You've kind of got the best of both worlds, and you can tap into sort of the left and right brain of the humans that you're trying to affect.
Okay, so next let's talk about what AI is doing today. Safety is a big concern around AI. I guess the first question is like, how do you define safety when it comes to AI?
That's a great question, isn't it? And is it a relative term? I think this is something that we saw recently with autonomous driving, and this is a great example of the qualitative versus quantitative, where quantitatively we know that in most scenarios, self-driving vehicles will be safer than a human driver on a population basis. But when the failure is based purely on computation and an AI model, it didn't really matter that we were overall safer because the reasoning or the reason why a failure happened had nothing to do with human judgment. And so safety, I think, is something that it's difficult because in most safety scenarios, the acceptable tolerance is zero. COVID is a great example where zero deaths is the target and zero deaths is the acceptable number. If we're trying to do some optimization of, say, distribution of PPE, we have to take into account how exactly are we going to attack that problem and zero for whom? Are we talking about all people equally? Are we talking about healthcare providers and frontline workers? Are we talking about children versus adults versus elderly? Are we talking about underserved communities? Building all of those things in such that safety can be achieved in the context that is balanced and in some way that we all agree on, I think is really difficult. So in some ways, I think safety is an impossible game, but that's no reason to sidestep it. There's lots of things that we can do there.
I guess what I take from that is safety is relative, especially with the autonomous car example. Whose safety are you considering? Is it the person not operating, but the passenger in the car? Is it the safety of people on the street? Are all human lives equal? So I think relativity plays a huge part in this, and it just makes everything that much more difficult. So, given that you can have these relative values assigned to safety, whose values should your system align to? How do you make those decisions? How can you make those decisions? Is it impossible?
I think this is a moving target. So a couple of thoughts. One is that I think safety you can think on the same continuum as an optimization, where safety is sort of the low end of failure, the low end of the continuum on the scale, and on the far side is some achievement of value gain. And traditional AI, and you could argue traditional capitalism, sort of takes this approach of an optimization. It's competitive, so there will be winners and there will be losers, and the goal is to win. So that's a traditional model. What we've seen, especially in the last several months, is that the definition of winning has starting to change. Even a decade ago, corporate social responsibility was coming into play, where the outcome for a specific firm could be directly correlated with how seriously they take sort of the long term approach of what they're doing versus a quarterly approach, which is primarily market driven. So, given that, and given that we're observing people, take consumers, for example, consumers and brand experiences being driven based on the overall impression, reputation, and corporate social responsibility, you now sort of need to think about that entire scale. And if you're continuing to play a game where there's absolute winners and absolute losers, then you're actually going to suffer, because some of those that would otherwise have gone along with your model won't want to play because they're exposed either directly through policy. You certainly can't do business with the government with that mindset, or you're getting down to some core issues around human consciousness. So I think the rules are changing in this space a lot, where building systems that are inclusive and can achieve a greater outcome for all are definitely what I see clients asking for sure. And it's becoming table stakes for deployment of anything to production. Not only that we can provide some assurance that we're able to achieve that sort of ethical stability, but also do so in a way that ultimately there's not absolute losers on the tail end of that spectrum.
It's an interesting challenge given that these tools are designed by engineers, and engineers have to design them not just for themselves, but they also have to consider everybody. It's kind of an interesting challenge of like, how do we design these tools so that they can even approach this optimization challenge?
Yeah, I think it's a two-sided coin. On one hand, the common criticism of AI is it's largely designed by middle-aged white men in Silicon Valley, which unfortunately might be sort of true. The flip side of that, though, is that engineers are remarkably good at dealing with dynamic requirements and assimilating new requirements in order to complete work. And so, where you see policy sometimes stumble, and you see committees gathered around ethical topics and other areas, sort of branding and marketing, sometimes challenged by this, engineering is happy to pick up a new requirement and design against it. So I think that's where we're just at the beginning of that broader understanding of implication. I think the timing is directly correlated to, as AI has an increasing effect on society, we recognize that this is cyclical. It's not about winning or losing the game. It's about a game that goes on forever. And everything that we do to influence that system will have an effect on it.
So, along the lines of technology being harmful, is how AI is being used today and designed for surveillance. What are some questions, or what are some ethical considerations around building tools such as surveillance tools?
Yeah, it's a great question, and one that I could spend all day talking about. I think again, you sort of sit on this spectrum where we can sort of put the marker anywhere on the spectrum that we want. We can do whole population surveillance, identification, and or we can go into specific scenarios that we care about. If we're a business, it might be relatively benign. I mean, imagine if you're a coffee shop operator and every time someone walks in the front door, it puts their first name and their favorite drink on your screen. I think that might produce a pretty nice experience for everyone. Some people might think that's kind of creepy, but there's
Yeah.
definitely good uses for this. And if you keep on walking on that spectrum and you move further out, you can start asking questions like, should we be able to tag known felons or people who are wanted as they walk through airport security if we limit the technology to that? What does it mean to have a false positive in that scenario? And how does that affect
Mm.
personal freedoms and liberties? Should we be allowed to deploy facial recognition in a prison? Is that a different environment that justifies its use? And I think, at the end of the day with these technologies, and facial recognition is just one of them, there's, all kinds of things that are moving quickly in terms of personal identification, triangulation of multiple data sources, consumer patterns,
Mm.
et cetera, where we started in one place and we're barreling towards another place. And when we started, we weren't really imagining these things. So most of the systems today that are doing facial recognition are doing so atop hardware that was deployed when this stuff didn't exist. So a live video feed was fed into a closed caption TV system that a security guard stared at. That's a very different scenario than one that is saving the same live imagery in high definition to a server where it will reside forever. Because just like with facial recognition, I don't think we fully understand in the future what the data we create today could be used for tomorrow.
It's an interesting thing to question. And I think the challenge gets back to what I was trying to say earlier, which is all these things are relative. And to go to your coffee shop example, like say 90% of people would love to have their face scanned and know their favorite drink, have the store owner know that immediately. And then what happens when 10% of people are opposed to that? Where do you draw the line when it's a spectrum is a one of those questions that I don't think we're going to answer here on this podcast, but it's definitely one that's interesting to think about.
Yeah, and it's something that has to be addressed in policy and by jurisdiction. And I think that's what we're seeing globally now is different reactions based on our own cultural differences. So what flies in Northern Europe will be different than what works in the United States, and that will definitely be different than what works in Hong Kong. And so I think across the board, these things have to be sort of worked out one by one and opt out. But for now, we live in a democracy in the United States, and we do get to kick these things around, and we have a system that we can refine policy in order to reflect sort of the current sentiment of what the population wants. But I think your question is spot on because it comes down to even if it's a 1% that's opposed, does that bring a system down that the majority accept? And it used to be that these kinds of topics were population based. And now, because of AI, we're all individuals and we're all individual entities in an infinite number of databases. And that's
Mhm.
definitely been the driver between what data policy has looked like historically and where we are now with policy like GDPR and in California, the CPPA.
Can you tell me a little bit more about data policy and how that's growing?
Well, I think it comes from going back to the point of future use. And this is something that since the beginning of optical disk drives sort of changed everything. We went from hand scribbled notes in one person's filing cabinet to bits and bytes that are potentially universally available. And policy around that can change over time. And so I think where policy today is sort of coming into play is more of an absolute stance on not only the right to be forgotten, but also the right to have some assurance that data about you has been purged and no longer exists anywhere. And I think generally that's the policy trend that we'll continue to see is that people have a right to take ownership of what they have. There have been a few attempts to think about how individual consumers might monetize through blockchain and other mechanisms their own data, so they become the controller of it. And the most
Mhm.
practical use of this we see today in healthcare, where it's just a natural sort of evolution that my health record would be able to follow me across different providers without all of the friction and sometimes fax machines that are required to do that. But I think we'll continue to see those kinds of trends move back as data becomes more personalized. It will become more owned by the person.
Funny you mentioned that. I actually work in an EHR company, so I will do my best to push that one forward. But next, let's talk about what AI is impacting today. And I want to start with automation and how it relates to job loss and labor trends. We've seen a lot of changes. The ride sharing business has sort of taken over the old taxi or rideshare business. That's just one example. Do you think that these sort of significant workforce disruptions should be taken seriously, and what can we do about them?
Yeah, that is a huge, huge question. And I think one thing that is not going to work is to bury our heads in the sand and try to shut down automation in order to save jobs. It's a
Mhm.
losing proposition, because even if you're able to do it locally, economically, you'll lose to those that are taking advantage of technology, and that goes all the way back to early agriculture days. In terms of any automation is going to make a very significant impact on the economic condition. I think another fallacy is sort of the retraining fallacy, that essentially for every job that someone loses, there's a better job for them waiting. That AI
Mhm.
automation is basically taking out a set of jobs that no one really wants anyway. And I don't think that's really true. You mentioned things like Uber or ride sharing. These are places where essentially what you have are workers pulling all nighters in their vehicle, while the AI basically operates as the boss and tells everyone where to go, when to go, who to pick up, how much to
Mhm.
charge, and how much they get paid. So it's really something that is affecting all every strata of the workforce, and you might even argue some of the more professional areas faster. I mean, it's hard to imagine a world in 5 years where most of the matters that you might take to an attorney, probably most as a population of the matters we might take to a physician, aren't directly solved through some form of AI automation. And so it's going to affect everyone. So I think that's point number one. Point number two, and this is something I'm really passionate about, is that actually AI is eating AI faster than anything. And a lot of the work that data scientists did, like me, even 5 years
Mhm.
ago, has gone away, because all of the technology around imputation and data cleansing, data loading, model selection, model tuning, ensemble building, these were all art forms, and something that people got paid well to go and do, and they were all bespoke by this particular application. But naturally, any place where you're doing a repetitive task, you can expect a computer is right behind you ready to take that job. And sure enough, that's happening in AI. All levels of data engineering, and even deployment and automation, security management, all of these things are becoming automated themselves.
So I guess the next logical question is like, what can we do as someone who designs these types of AI systems? Did you build a big red button in there that says like take a step back? We don't want AI being the boss. There's a place for ride sharing in the economy, sure, but can we take a step back and sort of reevaluate, or is it only forward?
Yeah, taking a step back is difficult, if for no other reason than the economic reason that the person that pauses will potentially lose. And it goes back to the comment around moving slowly and carefully, and I'll add to that inclusively, because you could look at Uber, and to be fair, Lyft, and everybody else in any form of gig economy. If the AI systems that are built to enable those businesses were designed through some form of discussion with all the stakeholders, things would definitely be different. And this is something, going back to the beginning of the conversation, I think I really benefited from working in a giant software company, is you do have the time to move slowly and do things right, and do so with people with all different kinds of backgrounds and skill sets. But I think, as a rule, if you can bring the stakeholders to the table, you not only ensure that you're not going to hurt people, that even if you're intending to help them, you're not going to hurt them, because I guarantee they'll come up with corner cases that you're not thinking about in the design of that system. And I see that all the time. I get to see that as a consultant who goes in and builds these things. But you'll also have something that is adopted more fluidly because you had more stakeholders. And I don't think this is anything specific to AI. I think this is just general statement about building and deploying systems of any kind, whether it's complete policy or complete technology. Having buy-in from stakeholders and having an inclusive design process that's iterative, that's the only path forward. The cost of that, of course, is time.
I mean, and money, it's difficult to sort of build those teams. That's its own interesting design problem. So I have a couple more questions here. I hope you have a few more minutes.
Sure.
So my next question is around sort of democracy and civil rights. The internet has sort of enabled this culture of fakery where robots and bad actors have been designed, customized to sort of generate viral content. In your opinion, like what's a potential repercussion of how we consume and process this kind of information?
Yeah, it's a great question. And again, it speaks to the challenges that we'll have in doing anything in the global sense. We're already seeing the effects of cross-boundary scenarios involving, exactly what you just described. Yesterday's hack on Twitter is a great example. One of the things that's interesting, so we'll use yesterday's Twitter security breach as an example. In this case, several well-known Twitter accounts were hacked and a Bitcoin address was placed there, and people were encouraged to send money to those wallets. But when you actually look at those wallets, it was only about $100,000 of cash that moved, which, considering the Twitter followers that represent those accounts, is relatively minor. I mean, that could have been one transaction. So I think one of the things that all of us, if we're not 13 years or younger, have to recognize is that we've now lost the ability to know basically whether or not something is true based on even verified sources. A green checkbox on a Twitter account. What could be more verified? But actually, it's not. And the same is true, as we now know, for photographs. Of course, we don't trust a photo that we see to be true representation of something that actually happened. Same with now video through deep fakes. So the reason I say 13 and younger is that I think the world kind of already knows this to be true. And unfortunately, we're in the middle of COVID right now, and we don't get to have interpersonal interactions. But I think it comes back to the sort of tenets of trust, and how do you develop trust between individuals, and then through that, groups, and through groups, brands, and between countries. I mean, all of these questions are related, but it comes down to veracity and really knowing with certainty that what you're seeing is true. And I think humans are naturally skeptical. We're a mammal with sort of a big brain, but not very sharp claws, and we can't really run that fast. So we're sort of wired to be naturally skeptical of everything that we see. I think that intuition will serve us well, and it becomes partly a human problem and partly an AI problem to solve, to filter and understand the difference.
You said that, and my head goes straight to like a Turing test that we're kind of doing every day on Twitter, looking at these verified accounts to determine if it's really whoever it might be tweeting those things, or if it's another person, or if it's a bad actor or AI. It's definitely an interesting test that we're kind of doing every day. Next, I just want to ask one more question about human to human interaction. How do you think AI is reshaping interactions between humans, and do you think it's a good thing for individuals and collectives?
That's a great question, and I'm going to have a biased viewpoint, just kind of where I live and what I do. But I will say that the nature of human relationships has changed. I don't think anyone can deny that the nature of who they stay in touch with and to what depth they stay in touch with them has changed. Trading email yesterday with a friend, we were calling each other Christmas card friends, because that's really where we see each other. But I think the Facebook friend is something very similar, where you feel like you have a connection, but the connection is based on a filtered broadcast rather than something that's genuine. And I think we're seeing with COVID now, there's a deep psychological impact to having interactions that are relatively shallow. Even interpersonal interactions digitally don't match physical interaction. And I think there's a lot still we don't understand about human psychology, that is we're making changes to a system that we don't yet fully understand. And that's the nature of AI by definition. But we'll continue to see that as being fundamental and important. I'm optimistic that we'll all get to go back to the AI conferences in person that we were doing before this, and maybe next time you and I can chat face to face instead of through the speakers. But I think that that's really a baked in desire into the human experience that AI has yet to fully approximate.
Yeah, it is. It is an interesting place we're in now. Like half of my meetings are, or all of my meetings, sorry, correction, are on Zoom, and it does not. It's nice to look at someone's face. Like there's a difference between even like having video on, video off, and sort of feeding those human needs is a difficult challenge. And I do think that the need for human to human interaction is so great that we'll never go to a place where a place that was described in The Machine Stops, where we're living underground in front of our monitors. I really think the human element will sort of overpower that. At least I'm hopeful.
Yeah. I think just one other thought there, having a data science viewpoint on this, it makes me think, what is the information that's actually missing? And there's so many visual cues, and everything from posture to sustained eye contact to gesturing that come into play in human to human interaction that we really don't yet understand. And I think we'll learn more. People are working on this in the space of robotics and elsewhere, but it's really a challenge that AI is just starting to get into, especially in unstructured data. We'll look at audio recordings and try to understand not only sentiment and topics, but also things like quivers in someone's voice that might indicate some feeling. And these are golden questions for a lot of important business scenarios, everything from law enforcement to net promoter score and brand affinity. I mean, these are the way humans express preference and from which we can predict action. And until we sort of have a good way of understanding these things, we'll never have systems that are either fully free of bias and ethical violations, but also really missing a lot of the accuracy potential that's there.
I guess the only way to find out and improve these things is to sort of try it. So, as much as we, well, maybe we can do a little bit of both, of slow and steady, and moving fast and breaking things.
Mm-hmm.
Finding that middle ground is going to be tough. Okay, so this wouldn't be a artificial intelligence podcast if I didn't at least mention general intelligence. And so the last question here is, how is present day narrow AI, and at some point this idea of artificial general intelligence, how's that going to impact our human abilities as we move forward as a species?
Well, I think the broader question you can think about there is human creativity. So going back to your chess example, you can think about a system can pretty well, in the context of a chess game, understand how you might have made different moves to achieve a victory faster based on its observation. But if at the analysis stage you looked at the outcome and said, that's true, except that halfway through that chess game, we decided that we were going to be playing checkers with the same pieces in the same places. And so all of the rules changed. So now I was trying to king myself, not capture my opponent's king. And I think it's a weak analogy, but that's really what we see all over the place and really defines the difference between generalized AI and applied AI. One of the examples that we work in is voice recognition. And you can think of it as sort of a couple of different situations. There's a specified context, which is like car navigation, where I'm speaking to my car and I'm only going to say a few things. I'm going to say rest area, Mexican food, things like that. And it will tell me where to go. And it has a working vocabulary around those things and will do a great job of that. The second is me being able to speak to the machine and through transcription being able to associate what I'm saying, extract some form of meaning, and then come back with a recommended response. The third, and one that we're actively involved in right now, is basically augmenting human to human communication. So this is a scenario where you'll never fully understand what two people are talking about. I mean, try doing it if you're sitting behind someone at a restaurant. It's hard enough just to try to piece together based on the limited context that you have as a human, but this is something that machines all around us are trying to do now. And so that third case, we have some knowledge of what the upper bound looks like just based on what the human experience is and trying to do this thing all the time. Anyone who's listening to this podcast is, hopefully trying to, understand what you and I are talking about, and hopefully I'm making a little bit of sense out of it. But it's not easy what we do as humans to try to do sense making out of human to human conversations. So I think that's the first place where we'll really see some breakthroughs is in those specific applied cases, but the source unstructured data can be very generalized.
That's an awesome point. And to go back to the analogy and sort of use it, I thought it was a great analogy because what I think you're trying to say with the chess analogy there is you can train an AI to play a game with specific rules and conditions. And the AI can, at this point, play chess better than any grandmaster in the world based on its computational ability and its ability to understand the rules in the space that it's in. But the thing about the real world, the world that we inhabit, is those things are always changing. The rules, the environment, it's constantly shifting. So it's really hard to program instructions that are able to respond to changes like that. And that upper bound you mentioned is very real because, especially when it comes to communication and understanding people, it's a difficult practice. And anybody that's participated in conversation, hopefully all of us, knows that it's not easy to really extract meaning. I mean, I listen to these podcasts after I record them, and sometimes I have a whole different experience listening to the conversation the second time, and I'm able to take out more from it, and it's a challenge that I think computers are up to a certain point, but humans we do have this kind of amazing ability to read emotion, read words, read body language, and extract meaning. So at the end of the day, I do think human creativity and those kind of things are somewhat irreplaceable, but I guess we'll wait and see.
Yeah, and I think certainly the advancement of the state of the art comes through human creativity. We talk at the beginning of the podcast about how the difference between AI and analytics is whether you're looking backwards or forwards. And the reality is that in as much as you introduce change based on AI recommendation, you're still doomed to repeat history if you're relying solely on recommendations that are generated from history. And so creative solutions that break a model and reset the rules, as you describe, are the ones that essentially win the day. And, this might be a silver lining around the question of labor force, where human creativity really becomes the capital. And I think most people enjoy being able to apply their creativity, and it's something we're all born with.
Well, I think that's a great place to end it. Creativity is king, and we're not totally irreplaceable because having these conversations about AI, it can feel like that sometimes. But before we get out of here, if the listeners have questions for you, what's the best way for them to reach you?
Sure. Feel free to drop a line at Cameron@Datorium. I'm also at cturner50 on Twitter and would love to connect on LinkedIn as well.
Great. All right. Well, we're going to end it there. If you liked our show, please subscribe wherever you get your podcasts and leave a rating or review. Thanks to Cameron for joining the show today. I think after listening to this, I'll have probably 100 more questions. So let's have you back on here soon to answer some of those. It's been a pleasure.
Thanks so much for having me, Oleg.